Okay, so this is going to be our limiting reactants portion of this review. We did a worksheet at the beginning of the unit that was sandwich stoichiometry, and I'm going to kind of use a similar example. Right now in my house, I have a bag of flour, half a bag of sugar, butter, I've got a gallon of milk, okay? I have enough flour to probably make, 12 loaves of banana bread. I have enough sugar to probably make 8 loaves of banana bread. I have enough butter to make 4 loaves of banana bread, and I don't even know how many loaves I could get out of a gallon of milk, okay? But I probably don't have enough bananas to make that many loaves of banana bread, okay? I have maybe 4 bananas, which is, depending on your recipe, 2 loaves of banana bread-ish, right? So my limiting ingredient is bananas. Well, in chemistry, we're going to do the same thing. I've got this much iron sulfide, 3.7 grams, and 2.3 liters of oxygen. Which one is going to limit how much product can be made, okay? Which one am I going to run out of, which will then stop the reaction and prevent any more product from being made, okay? That's what these questions are asking. So wrap your head around that. Hopefully that makes that a little bit easier to think about. So this question is saying, if we have 3.7 grams of iron sulfide and 2.3 liters of oxygen, which one's limiting my reaction, and how many grams of Fe2O3 can be made? So how many loaves of banana bread can we make, okay? So I directed you to a specific product, what we're trying to figure out, okay? So we're gonna do 2 different calculations. I'm gonna figure out how many grams of this I could make if all of that reacted. And then I'm gonna figure out how many grams of Fe2O3 can I make if all of the oxygen reacts. And whichever one gives me a smaller answer is going to tell me that's what is limiting my process, okay? So 2 problems. This one is grams to grams, okay? This one is a volume at STP to grams. So two different methods, but then we'll compare our answers at the end, okay? So start with what we're given. I'm going to do 2 calculations. This one is 3.7 grams of Fe2O3. That's one of my givens. My other given is 2.3 liters of oxygen. So those are my 2 starting points. I'm going to do this one first. Okay. Again, I am going from mass of substance A, FeS2, all the way to mass of substance B, which is my Fe2O3. Okay. So my first step, if you look at the molar map, is molar mass, which again, I wrote those up here so that we could save some time. So 1 mole of this is supposed to say FeS2. Let me just change that real quick. 1 mole of FeS2 weighs 120.0 grams. Okay. All right, that gets me to moles. My next step is going to be the molar ratio. Again, I'm trying to ultimately find how many grams of Fe2O3 can be made. So my mole ratio is FeS2 to Fe2O3. I have 4 moles of FeS2 for every 2 moles of Fe2O3 in this equation. So those go away. Now I'm in moles of my second substance, Fe2O3. And then the final step, to get to grams of Fe2O3, I'm going to need the molar mass of that substance. So 1 mole of Fe2O3, remember moles cancel, so that's why I want that on the bottom, is 159.6 grams of Fe2O3. So moles go away. All right, I'm going to get that answer in a little bit. This one I'm going to set up as well. Okay, this one though, I'm starting in volume. Remember, to get from volume at STP to moles, I need molar volume. So my first step is a little bit different. I don't care about the molar mass of oxygen, I want the molar volume. 1 mole of a gas at STP is 22.4 liters, okay? The liters are what I want to cancel, so I need the 22.4 liters of oxygen for every 1 mole of oxygen. So liters go away. Now my mole ratio, again, I am comparing my oxygen to what I'm trying to find, my Fe2O3. There are 11 moles of oxygen, which I want on the bottom to cancel my oxygen. 11 moles of oxygen for every 2 moles of Fe2O3. 2 moles Fe2O3. So the moles of oxygen cancel out. And then my final step is going to be the same as this one. 1 mole of Fe2O3 weighs 159.6 grams of Fe2O3. Okay, so those cancel out, and now both of my problems are going to end up with grams of Fe2O3, so I can make a comparison. Okay, so 3.7 divided by 120 times 2 divided by 4 times 159.6. This is, with only 2 sig figs, is going to give us 2.5 grams of Fe2O3. Okay. Now my bottom one, 2.3 liters of oxygen divided by 22.4 times 2 divided by 11, and then times 159.6. This one gives me, with 2 sig figs, so 2.97 is going to round up to 3.0 grams of Fe2O3. Now we have to interpret our answers in order to answer the actual question here, okay? I have enough iron sulfide to make 2.5 grams of iron oxide. I have enough oxygen to make 3.0 grams of iron oxide, okay? So it's like I have enough bananas to make 2 loaves, but I have enough flour to make 8 loaves. Which one's limiting, okay? The one that gives you a smaller answer is obviously limiting how much product can be made. So FeS2 is limiting, and that's how we would answer this. FeS2 is limiting. It is the limiting reactant. It is limiting our reaction. It will run out and stop the reaction. Okay? The other part of the answer, how many grams of Fe2O3 can be made? Well, this is it. This is where the reaction will stop because we're going to run out of FeS2. So 2.5 grams of Fe2O3 can be made. Okay? Now this is a little bit different than the way the book teaches it. If you're reading in the book and you're liking their method, you can go to YouTube, look for Tyler DeWitt Stoichiometry or Tyler DeWitt Limiting Reactants. He teaches it in the same way as the book. What we have found as educators is that way is a little bit harder for kids to wrap their brains around. So we teach it this way, and Melissa Maribel on YouTube also teaches it this way in much more detail than what I just did. Again, this is a crash review. If you want to watch her videos, she will go through it in much more detail to help you out. You can also always reach out to your teachers. Please email us, contact us somehow so that we can help you with these problems. Last video will be a really short one, and it will be on % yield.